Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resolution of a racemic carboxylic acid using an enantiomerically pure chiral amine works by forming diastereomeric salts that can be separated. For this to be possible, the acid must be chiral, exist as non-superimposable enantiomers, and must be racemic, a mixture of both enantiomers. Moving on to the next step. Identify the source of chirality in each option. Options A and B are polycyclic or benzene ring systems with substituents. For these to be chiral without a stereocenter, they would need to be axially chiral atropisomers or have some other element of chirality. However, A is a naphthalene with substituents that appear symmetrically placed, giving a plane of symmetry and making it a chiral, meso or symmetric. B is a benzene ring with two number 2 and 2CO2H groups placed symmetrically, also possessing a plane of symmetry achiral. Moving on to the next step. Option C is a biphenyl compound with the following substitution. Each phenyl ring bears one number 2 group and one CO2H group at the ortho positions, 2,2-dinitro 6,6 dicarboxy biphenyl. In this biphenyl, the ortho substituents, number 2 and CO2H, on both rings are large enough to restrict rotation around the central C-to-C bond, atropisomerism. Crucially, the two rings each have different substituents at their two ortho positions, one CO2H, one number 2, and the substitution pattern is such that the molecule lacks a plane of symmetry perpendicular to the biphenyl axis. This gives rise to axial chirality. The molecule exists as two non-superimposable mirror image atropisomers, Ta and Sa. Since it is a carboxylic acid and is chiral, it can be resolved by forming diastereomeric salts with an enantiomerically pure chiral amine. And for the final step, option D is a 9,10-dihydroanathracene derivative with CO2H and number 2 on the same or different rings. The structure shown appears to have a plane of symmetry or lacks a proper stereogenic element to produce stable enantiomers under normal conditions, making it either achiral or not resolvable by this method. A. The naphthalene dicarboxylic acid with symmetric nitro substitution has an internal plane of symmetry achiral, cannot be resolved. B. The benzene dicarboxylic dinitro compound has symmetric substitution with a plane of symmetry achiral, cannot be resolved. D. The dihydroanathracene derivative does not have stable axial chirality or a classical stereocenter that would allow resolution into stable enantiomers. Only option C, the 2,2-dinitro 6,6 diphenic acid, biphenyl 2,6,2,6 tetrasubstituted with number 2 and CO2H, possesses axial chirality due to restricted rotation around the biral bond and non-equivalent ortho substituents. It exists as stable Ra and Sa enantiomers that can be resolved by treatment with an enantiomerically pure chiral amine to form separable diastereomeric ammonium salts. Therefore, the correct answer is C. Therefore, the correct answer is option C.